Um, hello YouTube. Hi, welcome back. We're watching Styropyro's 2025 World's Strongest Handheld Laser. This is my first experience with Styropyro. As you can see, my friend created for them vouchers in chat. But if you like content like this, please feel free to like, comment, subscribe, and join us at twitch.tv/simply Azura to watch along with me. I'm always looking for new things to watch, and this is exciting. So we're just gonna jump straight in. Yay.
The legal power limit for a laser pointer is 5 milliwatts.
He, right off the bat, has some crazy eyes. I don't know if the quality's coming across so well on stream, but hold on. Yeah, but dude's got some crazy looking eyes. Holy shit, those are the bluest eyes I've ever seen.
Well, I think it would be funny to build one that's 50,000 times stronger than that.
Now, I've showcased a lot of ridiculous portable lasers on this channel, but so far, none of them come close to that kind of power.
Even my strongest laser, which was world record breaking when I built it, isn't even half of this level. Now, considering the advances in laser tech since I made this thing, I think it's time to build a laser pointer that just completely blows it out of the water. Now, I'll admit that more power isn't my only motivation here. This laser is horribly designed, and it is just plagued with issues.
I mean,
not only do I want the next one to be strong,
I mean, I haven't watched the first video like with this laser in it, but it doesn't look that bad. I mean, I don't know all the workings, so maybe I can't talk about it. Hold on.
I want it to be good and packed with cool features.
Like the last one, the heart of the new laser is going to be the best diode array that the Chinese black
Yo, that's crazy. That's a crazy shot. Holy crap. I'm gonna have to go back and watch the other video.
market has to offer. The kicker is that there have been 5 years of improvements on these things. The new arrays are stronger, brighter, and more efficient.
They still carry the same dubiously legal charm as the last ones, though, as they still ship with scratched out part numbers, and the manufacturer still denies that they even exist. Now, as long as I can input money into eBay to
I love this man. He's so dangerous. I love him. He makes so much dangerous shit. Enjoy his stuff. Oh my god.
acquire
Okay,
these,
I'll have to go into a
I'm
deep
not gonna
dive later.
complain. I mean, honestly, the feeling that I'm not supposed to own these really adds to the appeal.
I've hooked a new array up to a lab power supply as a test, and although I can't push it to full power on this thing, it gives an idea of the insanity that I'll be working with here.
Oh, yo, flashbang, flashbang. Holy shit, that's bright as
The
fuck.
array is the same physical size as my first one, but with more emitters
Also, why are closed captions on? Are those just in his video? Hold on, chat. We're gonna ragdoll.
packed in the same area, and according to the sketchy datasheet, it's rated for 161 watts of output power. I'm actually going to attempt to push it far beyond that using some overclocking techniques, but that's going to take more careful design than this piece of trash I built 5 years ago.
Now, if you think I'm exaggerating when I say this thing is poorly designed, well, it randomly quit working a few months ago, and I don't even know why. So let's open it up and see what's going on.
Does he like play with his lasers every little while just to see if they still work? How's he know it broke?
Now, it definitely smells crispy under here, but I don't actually see anything that's like burnt up. Well, it looks like it's the batteries. They are completely fried. I wonder if the dead batteries has anything to do with how you have to like smash these batteries into the laser. Like seriously, they don't really fit in here. You have to like crush the batteries. And like, yeah, if there's one thing that lithium batteries love, it's to get crushed like this. And the worst part is that because I didn't build a charger inside of this thing, you have to, take it apart every time and then crush the batteries again in like a slightly different configuration. Oh man, I'm very happy that this thing never operated in pipe bomb mode. The cooling in this
what
thing
mode?
sucks too.
Pause. In what mode? What does that writing say?
Because it's just this giant chunk of aluminum that doesn't have any real connection to the case there, so heat just builds up without anywhere to go. And then these laser drivers kind of suck too. I mean, if I would have used chips from the Sentry, they would be a lot more efficient than they are here. But you know what really cursed this project from the beginning? The very first sentence of the video. Hey everybody, it's the year 2020 and I want to celebrate. Now typically on this channel,
Hold on, he looked like a baby. He looked like a baby.
it's the year 20.
Holy shit, he looks like a baby.
2020 and I want to celebrate. Now typically on this channel, I like building crazy contraptions. Yeah, that didn't age so well, did it? So this time, I'm not going to celebrate that it's 2025.
Yes, hello, welcome in. It is Styropyro,
Instead, I'm
yes.
going to celebrate the fact that my channel has now made it 18 years on this platform without getting banned. And yeah, it's
How
not
old
like I
is
needed a
he?
reason.
How old is this man? What do you mean his channel's 18 years old? This dude don't even look 18 years old. What do you mean?
To build a bigger laser. But if I'm going to correct the issues from the first video, I might as well be comprehensive.
The one thing I did like about the first laser was the radar gun housing, so I bought another broken one on eBay. I took it apart and pulled out the cool old microwave circuitry, and then added my own control circuits, a charging port, and a bunch of switches. Next, I picked up some batteries, and
A lot of
assembled a
fucking
pack
batteries.
using a battery management board. This should hopefully reduce the risk of catastrophic failure, or even a
This dude might be honestly one step away from mad scientist already with all of this, honestly.
boring failure like over discharge. I needed a circuit to carefully drive the ever-living daylights out of the array. Usually I use an IC from the 70s for this, but in the interest of efficiency and size, I dead-bugged some modern purpose-built ICs for this task. Now I took a risk here, since I built these to far exceed the array's ratings.
This array is rated for 3.5 amps of drive power, so I decided that 4.7 would be a better number. Now yes, this carries the risk of destroying it early. However, with proper cooling, I think it should hold up. This will give up to 255 watts of output power, which obliterates the last one at 100.
Oh, this is some math I don't understand. Yeah, I don't get the math. Unfortunately, math was one of my worst subjects in school. I hate math with a passion. I tried to stay for an op. No kidding. This dude going against Michael Reese in a battle of no way they're that old. No shot. They're fucking any kind of old. I thought he was like legit early 20s.
I also added a PWM feature to the driver for audio-visual effects. I first tested this feature on a weaker array, and it worked better than I expected.
All right. This man against I did a thing. One of these two are gonna light their houses on fire first. It might honestly be this guy. My money's on this guy lighting his house up first.
That sound you hear is actually coming from the laser hitting the wood. Now this is where things got difficult. I still had cooling to deal with, and since I didn't want to machine an elaborate heatsink, I figured water cooling would be the better option. I picked up a water block designed for CPUs, along with a pump and radiator, and assembled a cooling loop. However, jamming all the plumbing into the case along with the electronics and batteries turned out to be very difficult. In fact, not long after finishing the laser, the control electronics burnt up randomly, and then
Yeah,
when I
burnt
rebuilt
up
them, they all
randomly.
burnt up again. The circuitry isn't even complicated, but because it was all free-wired, it was incredibly time-consuming to redo. I never actually identified the problem, so when I finally decided to try building it once again, I added all sorts of fail-safes against shorts and voodoo voltage spikes. The third time was the charm, though, it seems.
Every time he shows this thing, it's one step closer to looking like something that comes out of a cartoon. I swear to God.
As this version survived past initial testing.
I actually want to apologize to all my channel members and Patreon supporters that followed this project, because it took so much longer than I expected. However, as you're about to see, this is the craziest handheld laser on the planet, so I really hope it was worth the wait.
With an output of 250 watts, this laser eclipses the threshold for the highest laser danger rating by a factor of 500. That means that just 0.2% of the laser's power is
Yo, it's crazy shot with it in the snow. Holy hell. Look at it, chat. It's so bright.
already considered an instant blindness hazard, as well as a fire hazard. The luminosity of this laser is especially impressive as well, having more than quadruple the brightness of my 100-watt laser, as this one is a brighter sky blue color. It's funny because, even though I built this thing, part of me still finds it hard to believe that a device like this is even possible.
Let me give you a quick rundown of the features of this laser. So this switch right here turns the whole thing on. Then you can see the readouts there for the battery voltage and temperature. Then these switches right here are what turn on the water pump and the cooling fans, which are impressively quiet, I have to say.
The fucking CPU cooling fans is so funny to me. Death Star laser, no shot, right, gamer?
Then the safety switch is right here, which of course arms the laser. Then these knobs right here control the PWM frequency and duty cycle. But for the time being, I'm just going to leave these maxed out. And then the trigger right here is what finally fires the laser.
Oh, that's bright.
Pretty cool, right? I'm sure you're wondering, what can you burn with the world's strongest handheld laser?
Literally
Well,
everything. What do you mean, what can you burn with the world's strongest handheld laser? You can burn literally everything, including your ops. Man.
A lot of things. Now, spoiler alert, the real crazy stuff happens when you stick a lens on front and focus the beam to a tiny point. But let me first show you what the unmodified beam is capable of.
Why would you want to put a lens on it, bro? You're just... Okay, never mind.
Let's start
I want
with
to see
a
it.
block of wood.
I just want to see it.
The beam ignites the wood basically instantly, and you can even hear a little explosion as the pyrolyzed vapors catch fire as well. The small portion of the light that reflects off of the wood is able to illuminate my entire shop. That's a lot of light. Cutting electrical tape is a classic demo for a strong handheld laser. But of course, this laser is well over 1,000 times more powerful than what's needed to accomplish this. The tape is sliced as fast as
Is that actually how they test... Oops. Is that actually how they test the strength of lasers? Because that's crazy. Cutting electrical tape with a laser is the test.
and wave the beam across it. The same goes for any sort of thin plastic I throw in front of it.
My dude, I think if anything's thicker than a... I think if anything's thicker than like a millimeter, it's gonna cut right through it. Yeah, it's heat and current resistant. Yeah, okay, you know what? That makes too much. That makes a lot of sense. I even think of it like that. That makes a lot of sense.
A plastic cup is quite a bit thicker than the tape, but it doesn't seem to have much meaningful effect against the laser. The beam punches straight through it without issue.
I want to see the cup.
Oh, we're
Turn the
doing
cup.
plastic.
No, I wanted to see the cup.
Experiments. Let's pop some balloons. That was pretty quick.
While we're doing overkill, matches are unsurprisingly no match for the laser.
Haha.
Slow-mo shows that they make it about 2/100ths of a second before catching on fire. Newspaper
that's
falls in
crazy.
the instant ignition category as well. Just barely clipping the beam is enough to light it on fire. Any paper product is this way really, but paper bags make an especially satisfying sound from the flash pyrolysis.
Oh, that was nice. Hold on, I want to
might
hear that
think
again.
that
Hold on. I want to hear that again.
Make an especially satisfying sound from the flash pyrolysis.
Pleasure to my ears.
You might think that solder would be a challenge
Pleasant
considering
to
how reflective it is. But
solder? I don't think solder's gonna hold up at all, dude.
nope, it melts nearly instantly. A CD was the first real challenge for the laser. Of course, it still caught on fire instantly, but it took a while for the beam to punch all the way through. I think the sooty flame in front was attenuating the beam before it could hit the plastic. The end result was pretty neat though.
Yo, that looks
I
cool.
briefly talked about the PWM feature, and I want to
Does
show you what
anybody,
this
does
does.
anybody remember when people were trying to blow bubbles through CDs? Like they would melt the CD just enough and go through it and it would blow a bubble? Because that's kind of what I was hoping that he would do.
When it comes to burning.
That I don't know why this sound is so nice to my ears. It's so pleasant.
By switching the laser at audio frequencies,
Flash
the target
warning?
actually makes sound as it vibrates from thermal expansion and contraction. In fact, this effect went far beyond my expectations. And now I'm wondering about the possibility of building a musical laser. I'll have to save that for a different video though. Alright, now it's time to actually test this laser's true
Oh, God, the
destructive
lens.
power. I'm going to stick a big f-theta lens on front in order to concentrate the output to a point and maximize power density. Everything I've shown
That's
so
a
far can be
crazy. That is a crazy looking lens, chat. Holy crap.
accomplished by weaker lasers. So this is the point where I enter uncharted territory for a handheld laser. Let's start by trying something that the last record breaker couldn't accomplish, melting a penny.
Alrighty, let's try melting through this penny.
Oh, flash warning. Oh, my eyes.
It's on fire! What? Oh, that's crazy.
Oh, it's melting. He accomplished it, though.
To burn.
It melted, kinda. He accomplished it.
It burned the zinc inside. That's nuts. Wow.
It's hard to see the actual flame
His little wow, I don't know why or how, but it reminded me of Owen Wilson. Wow. Wow.
when there's so much blue light from the laser. But I did manage to repeat the effect and get a flame to sustain for a bit after turning it off. And as a bonus,
Oh.
it left a bizarre frozen smoke remnant of zinc oxide. The
Yo.
fact that the
That's crazy. I want to eat it.
laser literally lit a penny on fire is an astonishing result to me. I've done all sorts of mad science experiments with pennies over the years.
Those are the cleanest looking pennies I have ever seen in my entire
I've
life.
dissolved them in acid, treated them with cyanide, hit them with 1,000 amps, blasted them with other lasers, but none of those methods ever managed to light a penny on fire. Even torching a penny doesn't ignite it, it simply melts it. I think the reason the laser can ignite pennies is due to extreme local heating. The zinc that's being exposed to the laser is likely reaching its boiling point faster than it can transfer heat to the rest of the penny. Then the resultant jet of zinc vapor goes on to ignite on
What's the boiling point of zinc, chat? Does anybody know? Can anybody look that up?
contact with air. At that point, the heat from combustion can sustain the flame for a bit even after the laser is removed. I think that explanation makes sense, at least.
That's a lot of pennies, my
For
dude.
the next experiment, let's see if the laser can make it all the way through
1,665 degrees Fahrenheit is crazy.
an aluminum can.
I'm pretty sure this thing will burn through one side of the can, but to go all the way through, that's what I'm not quite so sure about. But, let's give it a go. Oh, wow, it was just instantly.
Oh, I didn't get to see it. Hold on.
This thing keeps surprising me. Pretty sure this thing will burn through one side of the can, but
Hold on, chat. I'm gonna scoot. So I'm gonna slide out of your way so you guys can see. Okay, ready? The can's right behind me, right here. All right, ready?
to go all the way through, that's why I'm not quite so sure.
Being exposed to the laser.
It was just instantly. Pretty sure this thing will burn through one side of the can, but to go all the way through, that's what I'm not quite so sure about. But, let's give it a go. Oh, wow, it was just instantly.
Crazy, dude. That's crazy.
This thing keeps surprising me. That's insane.
The last record breaker couldn't defeat an aluminum can either, so the increase in power is pretty obvious here. Let's see if the laser can open up this glass soda bottle.
Yeah,
What could possibly go wrong?
everything. Okay, prediction. He's not gonna get through the glass instantly. Instead, he's gonna flash boil the liquid inside the bottle, and it's just gonna explode. That's my prediction. Yeah.
Oh my gosh!
I'd be really scared if you look at the way that light's refracting back
gosh.
at him. Hold on. I'd be really scared of that refracting back into me. I would not want that. That looks scary.
Oh my gosh! Oh, I'm so happy it exploded like that.
It was very satisfying pop though. I'll give him that.
Oh my gosh. It was like a glass balloon.
That was fun. Let's pop another one for good measure.
So satisfying.
Well, it's not exactly an ideal bottle opener there, but that was pretty cool.
I wonder if the laser is strong enough to punch through drywall.
I would assume it is.
You're kidding me. Wow. It's white.
I need to hear the pop again for it going through the drywall. Hold on. 1 second, chat. Listen closely, chat.
You're
I don't know why the little poppy sounds are so satisfying to me today. It's very nice.
kidding me. Wow. It's white. You'd think that it would like reflect off all the light.
Mhm.
That's bonkers. I would have never thought that that would be possible
That's actually a pretty clean cut, honestly.
with a handheld laser. That is ridiculous.
Also, I wonder if he like bought a piece of drywall just to cut this little square from it, or if he just cut a random spot from a wall somewhere. That'd be really funny to me.
In the early days of big pulse lasers, before there were precise methods of power measurement, lasers were measured in gillettes. Now, this literally meant how many Gillette razor blades the laser could shoot through in one shot. Now, this kind of
Interesting.
measurement doesn't translate to a laser that can operate continuously. But even so, I want to try shooting through some razor blades.
I even found some Gillette blades from the time period
So this guy has casually built a laser that can do this? Yes. We watched that in the first part of the video.
of
Yeah, he
early
built it.
lasers to try this with.
All right, moment of truth. Is the laser at least one Gillette? Let's find out. Oh yeah.
It didn't even phase it. It just went right through. What did this man expect?
Not even a challenge. That was instantly. In fact, I want to see if I can actually cut this thing in half.
Yo, that's crazy. That's so crazy.
Wow.
This dude essentially already has a laser gun.
Yep.
Now let's see how fast it can punch through 5 blades in a row.
All right, here we go. Jeez.
Dude, that took fucking 1 second. Crazy.
That is so wild. Wow, that's terrifying, honestly.
The way to make the Gillette measurement make sense with my laser is to convert it into a rate, essentially going from units of energy to power. Since the laser burned through 5 blades in 0.9 seconds, I can say the laser has a strength of about 5.5 Gillettes per second. Let's try a utility blade that's more than 6 times thicker than the Gillette.
I think this laser is battery operated. I think he said earlier in this video. He's got lithium batteries in it, if I recall correctly.
No problem there. Considering how fast the laser can melt holes in these razor blades, now I'm going to try welding 2 of them together.
All right, time to test out.
Are you even gonna be able to weld them together? I feel like you're just gonna melt them into a sloppy metal mess.
If this thing can weld? I can see it glowing and sparking. That's gonna be a good sign. Well, I melted through. I don't know if I actually welded it, but let's take a look there.
You know what? Real note though, I'd be scared as fuck to hold this thing. I'd be scared as fuck to hold it. Like, for real, I feel like I would light myself or somebody around me on fire.
Yes, it did. It actually welded it. No way. And look at that. It actually welded that. Now, if anything, I should have moved faster just because where I held it too long, it burned all the way through. But it legitimately is holding that together.
That's crazy work.
Let's see if the laser can melt through copper wire.
All right, here we go.
Is copper wire hard to melt? Like, is that a thing?
Oh, it's melting. I think it's gonna work. Yeah.
Yo, did you guys? No, it's soft metal. That makes sense. Did you guys see the way that was reflecting back onto the wall? Look at that. Look how cool that looks. Look.
It'll work. Yes. Well, there it is. Wow. Well, this thing's really going toe-to-toe with a microwave. I would have never guessed that.
Macrowave?
This seems
I'll
like a
have to check out that video
stretch,
next.
but I'm going to try punching through this piece of titanium here.
All right, let's see if this works. No way. What? It just shot through instantly. It shot a huge hole through it. Just instantly. That's insane. Now, titanium is not something that just
Yeah, that is just that's crazy work, dude. That's insane.
melts easily. And as a demonstration, I have this torch here. So, I can hold this here all day. It's not gonna melt. This one's really surprising to me.
In my last video, I built a 20,000 watt microwave, and in one of the experiments I used it to make ruby. However, the
He did a what now in his last video?
setup was far from ideal. It was impossible to concentrate the energy, and my containers kept exploding. Thus, the rubies I did manage to make were pretty small. I'm going to see if the laser can do it better.
Casually just making rubies. That's insane. What do you mean?
The starting mix is the same as last time. alumina powder with a couple percent chromia added, which I got from Nighthawk and Light's video on cooking up rubies in a home microwave oven.
Yeah, don't ask me about the name on that one. Alright, let's try cooking some ruby. Now it's sparking. I don't know if it's actually... Oh, it's so hot. It's just glowing so brightly through these goggles.
I'm fascinated, chat.
Oh wow, that is so hot. Oh my gosh.
It's fucking glowing. It's glowing, bro. That's crazy. What do you mean?
I had no idea it was like just melting it so well. It's crazy. I think I just made a huge ruby too. No way. I can't believe it's gonna work this well. This laser just keeps surprising me. Oh, it melted like a big old glob. I think it like beat the daylights out of the microwave actually. I had no idea that it was cooking that well. And look, it just made an enormous, huge ruby. What? That's crazy. It's huge.
This dude is insane. I agree, he does need contracted by the US military. Holy crap. This dude's insane. What do you mean?
Huge. What? It just made this giant ruby. That is crazy. In fact, I'm gonna go ahead and give this guy a pluck. My gosh, it's an enormous, enormous ruby there. I'll clean that off and make another one here quick.
This turned out to be a really reliable method to make big rubies, and it blows the performance of the microwave out of the water.
Yo, they kind of look like cranberries, honestly. But that's insane, dude. That's crazy work.
Even freehanding the laser produced bigger rubies than I was able to get via the microwave. I'm very impressed with the size of these. I've never offered merch before, but I don't think anything could beat laser-grown ruby as my first product.
Those are so pretty. Bro, those are so pretty. I love the coloring on those.
So I made a few extra to offer my viewers. Check the link if you're interested.
They're gone, I bet.
I'm curious whether white sand is reflective enough to resist melting in the laser beam.
Do you guys think he can make glass with that laser? Do you think he can melt the sand down into glass? Do you think it gets that hot?
Oh yeah, just instantly melting. Oh my gosh, it's so bright. Even through these goggles. Oh yeah. Wow, look at that stuff glow. And it's white too, like you'd expect it to just reflect it all away, but nope. It just melts straight through it.
Ooh.
That's just bonkers, man.
Considering how well everything else has worked, I'm going to try zapping tungsten wire. Now, as a reminder, tungsten has the highest melting point of the metallic elements.
This is crazy that I'm even going to try this one. Oh my gosh. Oh, it's so close.
Yo, that's a crazy shot.
I don't know, man. I'm gonna have to get the focus better. Oh, it was close, but I think it was slightly out of focus. So I'm gonna move this back just slightly and try it again.
Yo, that's insane.
Alright, I think I have it lined up better this time. Oh. Yes! It worked!
Yo!
Oh my gosh, I cannot believe that.
I need him to get a temp on like how hot this laser runs. That's insane.
That is insane. I would have never expected this laser to go like toe to toe with a microwave. My goodness. That's crazy. It's crazy.
The wire burned here instead of melted, but even so, that still takes some incredible temperatures. The only other extreme material I can think to test the laser against is diamond.
Oh,
So I
diamond.
picked up some synthetic diamond stillays. I honestly don't know what to expect from these.
So by some chance, can this thing burn through diamonds? Let's find out. Oh, they're burning. They are absolutely burning there. Oh, I think one just exploded.
Fucking exploded diamonds, bro. I mean, granted, it's synthetic diamond, but still.
There. Oh, I think one just exploded.
That's crazy
Wow!
work, dude.
It actually lit a diamond on fire. Wow. That's amazing.
I guess it shouldn't be so surprising that diamonds burn, considering they're just carbon.
Are you gonna read
I'd
that?
fire the
Yep.
laser up my ass so I can shoot atomic beams like Godzilla.
Bad, Pandroid. Bad.
But it still takes a very hot temperature to ignite them, and they reflect a large portion of the laser light anyway. In fact, the diamond reflections are particularly scary, since the crystals reflect
Oh my god, yeah, I didn't even see that. Look at the background, like as the diamonds like
they reflect a large portion of the
reflect it.
laser
Look.
light anyway. In fact, the diamond
at it.
reflections are particularly scary, since the
That's I mean, yes, it's scary, but it's also so very pretty.
crystals reflect intact portions of the beam and result in a terrifying disco ball of insta-blindness. My goggles protect my eyes just fine, but I'm glad none of the beamlets hit my cameras, as I'd hate to destroy all my cameras again.
Oh, that's interesting how it like changed allotropes there. It turned to like amorphous carbon there in the center, and you can still see some, unlazed diamonds there on the side. Oh, that's weird.
insane.
That must have got really hot. I could see some of them burning too. I could see the sparks flying out. But yeah, it changed the allotrope.
Lithium coin cells aren't exactly as tough as diamonds, but they turned out to be a lot of fun to zap.
Whoa.
Their metallic lithium content makes them quite pyrotechnic when they
Oh,
fail.
look at the reflection. Look at the reflection as it's like melting.
Yeah.
Down below, hold on.
The lithium content makes
Look
them
at it.
quite pyrotechnic when they fail.
Heck.
Interestingly,
Dude needs a gas
the
mask
effect
for his
depends
own
on
garage.
which side is hit by the laser. Blazing the positive side is what gives a rocket-like effect, with flames colored red from lithium's atomic emission spectrum. Hitting the negative side is what makes them pop more violently.
That's crazy, dude.
Oh, there's lithium burning on there. Oh boy. One of the batteries even splattered some
Oh.
molten lithium on the laser lens. Oopsies.
It looked like it was burning
So
my
I have
head.
an old style ping pong ball here. Now these old style ones are flammable because they're made out of nitrous cellulose. But the problem is it's hard to find those locally, so I have to order them online. But because I've bought these online, now I get sent this physical spam in the mail from Paddle Palace. It just sounds so bad.
Paddle Palace sounds like a kink shop, bro. I'm weak.
But I don't play ping pong ball. All I do is just blow these things up with lasers. So anyway, I'm gonna shoot through one with this huge laser here.
And yeet.
Ooh. You know, that was satisfying to watch burn. Hold on.
This huge laser here.
And yeet.
Oh, I didn't mean to pause again. Sorry, chat.
Yeah, just instantly. Typically, when I make videos about my lasers, I show you all the cool stuff that they can do and leave out what they can't. But you know, some of the failures are even more interesting. So, what are some surprising things that this laser struggles with?
Burning a hole in a CD case is a classic demo for a powerful handheld laser. Going back to the archives, it shows that a 1-watt laser takes a few seconds to pull this off. So, does this laser do it 250 times faster? Nope,
I would assume it
it's
would melt.
actually slower. What's going on? Sometimes there's a paradoxical effect with lasers, where increasing the power weakens its effects on materials. Flames, smoke,
Oh, I'm jealous of the laser ruby cream. That's so fun. Congrats.
or even plasma from the laser hitting the target can absorb most of the laser light and protect the material beneath it. This effect is very prominent with pulsed lasers, and explains why this laser can pop craters into tungsten, even though it struggles to pop a balloon. The CD case immediately shot a jet of sooty fire when it was hit, and I think that played some protective effect. I've also noticed that some materials can become self-healing to an extent when more power is applied. For example, my laser welding system actually cuts steel faster with the power turned down. At full power, even when the beam does punch through, the hole tends to immediately close back up when the laser is turned off. The reasoning is that the higher power results in more molten material that can fill in gaps. I tried another CD case at roughly 10% power using the PWM feature. Sure enough, it burned through faster with less power. I then tried it at full power, but slightly out of the focal point to lower the power density. Since it didn't catch on fire, the laser shot through almost immediately.
I always say that most problems in life can be solved with very powerful lasers. And although this may seem like an exception, the reality is that the problem will go away if you throw even more power at it. The issue is that more power isn't always possible, at least based on engineering constraints or even the current state of technology.
Mirrors also showed some self-healing effect. Ironically, it was the shiny part that burned, while the glass simply melted and prevented total burn-through.
Oh.
Another surprisingly difficult task for the laser is igniting flammable liquids. For example, I've got this glass of butane.
High key. Okay, he's got butane first. First of all, his haircut kind of looks like the edges of his hair were burned. Actually,
Here, and oh, look how angry that is. They're just like boiling away. Just the tiniest little spark is all it takes to turn this thing into a fireball. So, what happens if I shine the laser at it?
Absolutely nothing. The thing about flammable liquids is that it's really their vapors that ignite.
oh, that
It's
was
easy
pretty
to
fire.
imagine a laser as just a long-distance torch, but unlike a flame, the energy from a laser has to be converted to heat via absorption by a material. The problem with vapors is since they're transparent, they don't absorb light and thus they don't heat up. You can get around this with a laser many
He does kind of like Timothy, whatever his name is, right? Right? High bolts recommend.
thousands of times more powerful, as at that point you can initiate a spark via the electric field. But for a laser like this, I have to cheat and add something else to burn that can then go on to ignite the liquid.
Chevrolet, yes, Timothy Chevrolet. That's the dude.
I figured that the plastic case of a lighter would provide enough flame to ignite the vapors released when it pops, but even this turned out to be a challenge.
Are you serious?
I eventually got one to go up in a nice fireball though.
Ooh. Oh, that was a satisfying sound.
I did find that with this laser, I can just pour a flammable liquid on the floor and then ignite it by pointing the focused laser at it. I'm still cheating by heating the concrete to super high temperatures, but still my first handheld laser that can at least do this. It's crazy just how much power it
that's
takes to
crazy.
get to this
Pretty
point.
fire.
What about snow and ice? One of my most common suggestions is to make a laser that can quickly melt snow off of driveways and sidewalks. But unfortunately, lasers suck at this. Snow is highly reflective,
Is he out in the fucking snow with socks and shorts? What is wrong?
so most of the light bounces off instead of heating and melting it. The bigger reason, though, is that ice takes an enormous amount of energy to melt. Water is incredibly stubborn thermally, and in order to get it to change phases or even temperature,
The way this looks in the snow, I said it earlier in the video, but I stand by it now. It looks so insane. It's
you
so
have to dump
pretty.
in a ton of energy. My much bigger and stronger laser welder can slice through about anything, but when it comes to snow and ice, it hardly makes a dent. Yes, that's running at the full 2,000 watts there, yet its effect on the snow is barely noticeable. The
Yeah,
full
that's
power
crazy.
only becomes apparent when I hit something
My
other
God.
than snow with it.
You know what, chat? It looks like a comic book weapon in a good way. That's what I said earlier. He's got a nice back.
In fact, this laser will melt steel faster than ice of the same thickness. Funny how that works.
I would assume his laser keeps him warm, honestly, Bolts.
Assuming perfect 100% light absorption and ice right at the melting point, my handheld blue laser could, in theory, melt 0.75 grams of ice per second, or basically 1 ice cube per minute. This is a great example of how lasers aren't impressive for their raw power, but instead excel in power density.
Since I'm claiming that this is the most powerful handheld laser in the world, I need to make some clarifications. So by handheld, I mean something that can be, comfortably held in one hand and also has its own enclosed power source.
So an example of something that wouldn't count towards this would be my laser bazooka. It's portable, but way
Laser
too big to be considered a handheld. It also sucks.
Yo, that's insane too. What the fuck in the cartoon comic book supervillain is this man?
Another example would be my laser welding and cleaning machine. Yeah, the output is fed through a handle, but it's tethered to a 400-pound machine that doesn't even have its own power source. So no, that's not handheld either.
Another important distinction when I'm talking about the most powerful laser is I'm referring to CW, or continuous operation. Pulse lasers can achieve far higher peak powers, but only for a tiny fraction of a second, and in general, they're much less destructive than CW lasers.
For example, this laser I built nearly a decade ago achieves higher peak powers than what I showed in this video, but only for billionths of a second. Overall, it's a much weaker laser.
Now, funny story, I was actually contacted by a very large record book company about the original record breaker,
Thank you for
but I didn't
hydrating.
pursue it because it involved having the power verified by 2 independent sources. Now, don't get me wrong, this is a very reasonable expectation, but it's actually kind of hard to pull off. So a laser power meter that can measure hundreds of watts is expensive, and it's just not something that's like commonly encountered. So only a few companies and universities are going to have something like that. But the bigger issue is that most people that work with big lasers for their career aren't going to want to be near lasers like this. Like, it's easy for me to get desensitized to this kind of stuff, but no, this is a psychotic project.
Yeah, no
And
kidding.
I can only imagine the aneurysms that OSHA and lab safety would have over these things. And even if I did find 2 people willing to test this laser for me, it's not like I can ship it or take it on a plane with me. It would have to be within driving distance. And because where I live isn't exactly the mecca of photonics, looks like you're probably just gonna have to take my word for it for the time being. Earlier I said that this thing is 50,000 times over the legal limit for a laser pointer. So, does that mean I'm going to jail for making it? Nope. So the cool thing about US laser law is that limit only applies to the sale and import. So there's nothing stopping me from making death rays in the comfort of my own home. Now, of course, I can't go out and sell this thing or play with it in a park, but I can show it off on a YouTube video.
One additional point I should add is that the US laser pointer limit of 5 milliwatts is actually quite lax compared to the rest of the world. Canada, Australia, and most of Europe set the limit to 1 milliwatt. So if you're in one of those places, my laser is actually 250
No wonder. The U.S. is more lax about it. Yep, makes sense. Adds up too well.
50,000 times stronger than anything you can buy. Now personally, I think 1 milliwatt is too restrictive, since that's hard to see in a well-lit room. Besides, even at 5 milliwatts,
Hell yeah,
the data shows
Viagra.
that our blink reflex is fast enough to prevent eye damage from a direct hit.
One final point I want to cover is safety. So my more recent videos have dealt with projects so extreme that I haven't even bothered with the whole don't try this at home bit, just because honestly, this kind of stuff is beyond what can be replicated without specialized tools or equipment. And yes, this laser is so far off the laser danger rating scale that its eye hazards are incomprehensible. However, that's not what I want to talk about with this bit. I want to talk about handheld lasers that you can buy online.
If you have a laser that looks like any of these, chances are that it's quite a bit over the legal power limit and can cause permanent eye damage from even an indirect reflection. A laser doesn't have to be record-breaking to obliterate your retinas if misused. I realize this warning may seem ironic coming from me, but laser eye injuries are unfortunately very common today. I've covered this topic more in depth in some previous videos, but the gist is, tread very carefully with lasers bought online.
Now I have to say, I'm glad to finally finish this project and put it behind me because it felt like every single part just took way longer than expected. So a big thank you to all my channel members and Patreon supporters for sticking it out, and really for making projects like this possible. And I also want to give a big thank you to Opera for sponsoring this video.
Yeah, that's what we're watching
I've been
this
using
video
Opera for a
on.
while now, and it's the fastest browser I've ever used.
At a university
On the
lecturer that
surface,
would point
it simply
at
loads
students.
pages
That's
quickly.
crazy.
Where it stands out is in its time-saving and productivity-enhancing features.
For example, my
Some
favorite
professors
feature
shouldn't
is
be
Tab
professors.
Islands. It's crazy how quickly a browsing sesh can lead to 30 open tabs.
Yeah, no fucking
and Tab
kidding.
Islands make it easy to revisit those tabs by grouping them by topic. I find this to be super useful when researching for my projects, since they neatly expand and collapse.
That's actually really cool. I didn't
Plus,
know I could do that with
tab
Opera.
traces make it even easier to find my most recently visited tabs, thanks to a subtle underline. The more recent the tab, the darker the underline. I also love the split screen feature because it allows me to open 2 pages in the same window.
I also
This
didn't know
is
I could do
useful
that.
for
That's
all
insane.
sorts of
I
scenarios,
like Opera.
like cross-referencing schematics, fact-checking articles, and comparing videos. It simply activates by dragging the tab down. The sidebar is great because it allows me to quickly access my various
I
socials.
do love the sidebar.
And in particular, it also contains an in-browser player. I can listen to music on 6 different streaming services without interrupting my browsing, since pausing or skipping a song is as easy as hovering over the player button. I can even detach the player and move it anywhere, including outside the browser window. Opera allows me to customize my entire browsing
I do
experience
like that
with
it
dynamic
does have a
themes.
pop-out browser
These go
like
beyond
window.
a simple light or dark mode by tailoring my browser to fit my mood. The integrated AI Aria is super useful as well. I can instantly bring up the command line with a shortcut, and then have it summarize pages, generate and interpret images, and answer questions I have.
So yeah, if you're wanting a faster, more productive, and customizable browser, you should give Opera a try and click the link in the description.
Thank you again to Opera for sponsoring this video.
I do like Opera.
Well, until the next time, stay safe and happy lazing.
Alright, thank you guys for watching. We're not watching this again. Thank you guys for watching with me. If you like content like this, please feel free to like, comment, and subscribe. And feel free to join us at twitch.tv/simply Azura. We like to watch stuff like this together weekly. And I'll see you guys in the next one. Goodbye.